Hello there. Welcome to the Microdosis for Brain Health program. On this first lesson, I want to talk to you about a very large subject, and I will get a little scientific, not too much, but enough to paint a picture of how stress and hormones are directly related to cognition. There's a secret cord that connects estrogen, stress, sleep, and inflammation. And when that cord is discordant, the brain's music changes. That's my poetry for today. When estrogen falls during perimenopause and menopause, several systems that support mental clarity begin to change. We already talked about energy metabolism, receptor dynamics. So now we talk about how stress hormones, sleep disruption, and inflammatory signals become part of the cognitive landscape, especially at this time of our lives. And so let's begin with stress. When the brain senses a threat, emotional, physical, even internal uncertainty, hundreds of involuntary responses and functions are activated. The body releases adrenaline and cortisol, the quintessential stress hormones, and glucose is released, supplying the fuel you need to deal with this perceived threat. Cortisol's job is to mobilize energy, right? Sharpen focus, prepare the body to act. Short-term stress is super important. It's a built-in protective reaction, like we call hermetic stress. But when cortisol is elevated all the time, and this is what happens when we have chronic unresolved stress, this becomes a burden rather than a benefit. Elevated cortisol shifts the brain into a state of hyper-alert survival mode. And this may have been good and well in the savannah, but in the modern world, it leads to hypertension, obesity, sleep disorders, difficulty sustaining attention, trouble recalling memories. In a sense, structural brain changes that cloud mental sensations. And this is what we call brain fog, because cortisol actually interferes with how neurons communicate. And that can degrade neurotrophic factors that support healthy synaptic connections, right? And it's basically cumulative wear and tear, no? The stress on the nervous system that does not give in. So the brain starts to protect itself by dialing down certain functions, especially those that are not immediate for survival, like deep memory, encoding, flexible thinking. So changing our response to stress with the help of microdosing is the ultimate goal here. Now we talk about sleep. So estrogen, progesterone are intimately involved in sleep regulation. They influence neurotransmitters like serotonin and GABA. And when those hormones decline, sleep becomes fragmented, hot flashes, insomnia. And, without restorative sleep, the brain can't do its nightly housekeeping. So deep sleep. This is when the brain clears metabolic waste. Something amazing happens here. We consolidate memories, we restore energy balance, but when sleep is interrupted, the clearing process slows down and new neural networks responsible for focus and recall are less efficient, right? So now it's not just brain fog during the day, it's the residue left behind when the brain does not get to properly rest. And now let's add inflammation to the mix. And inflammation, it's not just about swelling or pain. Inflammation is a chemical conversion between the immune system and the brain. Chronic stress increases inflammatory signaling, as simple as that. When inflammation is elevated, again, this disrupts neurotransmitter function. This impairs neural communication, yeah? What happens again? Reduction of clarity of thought. So even mild inflammation affects attention and our ability to process information efficiently. This is key right now in the specific cycles and transitions that we're going through. So what we're seeing now in our midlife brain is fog is not just one cause, but is a web of interconnected systems, right? Hormonal shifts, that change of energy metabolism is also weakening the systems that regulate stress resiliency, sleep quality, inflammatory balance, those three. And so those three wobble, the brain enters a state of reorganization and compensation. So what happens is something that could be a manageable transition becomes into cognitively heavy, emotionally charged experience. And this is where we begin to see why microdosing can be supporting. Not magical, not curing, but it facilitates adaptation. Microdosing is not about supercharging the brain. This is not what we're trying to do. We're not even trying to tell the brain estrogen doesn't matter anymore. It's about supporting the nervous system during a time of flux. Low-level psilocybin gently upregulates neuroplasticity and helps the brain explore new communication patterns. During this period of metabolic hormonal restructuring, microdoses can help the brain navigate the tension between those old pathways and the new ones, supporting clarity rather than collapsing into this exhaustion that we may perceive right now. One of my mentors, Dr. Claudia Welch, frames hormones not as isolated actors, but as part of an overlapping system that live in what she calls the buckets. And they all share these common precursor pathways. In her work, she emphasizes that the body is going to prioritize based on immediate needs, especially survival needs like stress responses. So when stress becomes chronic, the body allocates resources to cortisol production at the expense of other hormones like progesterone and estrogen. This is fascinating. It's something describing endocrinology as the pregnenolone steal. I'm not going to get too deep into this, but I want to explain a little bit of how this plays out across the endocrine axis. And again, coming back to stress, because stress is not just emotional experience, it is a hormonal event. During midlife, it becomes a central driver of what we experience as brain fog. So to understand this, we need to zoom out and look how the endocrine system reallocates resources when ovarian hormone production declines. And this framework is really useful because we can see that hormones operate in interconnected systems that draw from shared physiological resources. And these systems, they compete and prioritize based on what the body perceives as most urgent. So in simple terms, the body cannot fully support reproduction, repair, metabolism, and stress response at the same time when survival is perceived, right? Stress hormones will always take precedence. And cortisol sits at the center of this prioritization. Cortisol is produced by the adrenal glands, and its role is to help the body respond to threat. What cortisol does is incredible because it mobilizes energy. It's going to raise your blood sugar. It's going to increase alertness. So temporarily, it's going to suppress functions that are not immediately necessary for survival. I'm repeating myself here because this is key to understand the huge role of stress at this transition in our lives. So this is adaptive in short bursts, but it again becomes disruptive when it's sustained. And this is why I want to emphasize together to work really diligently to lower our chronic stress response. During perimenopause and menopause, the ovarian production of estrogen and progesterone obviously declines. We know that. So at that point, the body is going to rely more heavily on other glands. And these are three specific ones I want to talk to you about. And we're going to begin with the adrenals, right? This is a normal compensatory mechanism. However, the adrenals have a primary job, which is managing stress. So stress, chronic stress, emotional stress, cognitive overload, a history of trauma that has not been worked, sleep disruptions. The adrenals are going to prioritize cortisol production, but they don't have an unlimited capacity. So when the cortisol demand is really high, then we create this kind of hormonal, physiological bottleneck. And in real life, what happens is we observe hormonal depletion because we're diverting shared precursors away from estrogen and progesterone support, which we needed very much. So chronically elevated cortisol affects brain function directly. Yeah, because cortisol will affect the hippocampus, which is critical for memory formation. Prefrontal cortex, which governs attention, focus, planning, executive function. Elevated cortisol reduces synaptic plasticity, interferes with the memory, new memory encoding. And over time, what the brain is going to do is just conservate, right? I'm less flexible, I'm less efficient, I'm more reactive. And this is not damage in a catastrophic sense, but it's functional suppression. Now, the secondary gland that gets affected after the adrenals is going to be the thyroid. The thyroid is going to be regulating metabolic rate at a cellular level, right, including the brain. Thyroid hormones determine how efficiently cells convert fuel into usable energy. This means that blood tests may appear normal sometimes, but your tissues, including brain tissue, is going to be experiencing this relative hypothyroidism. Clinically, shows up as reduced verbal fluency, mental heaviness, fatigue, cold sensitivity, decreased motivations, and these symptoms sometimes can overlap with this brain fog. But the driver here is metabolic, it's not cognitive. This is where I get a little scientific, but it's important to understand. And the third gland that will get affected is going to be the pancreas, insulin, glucose regulation. Cortisol raises glucose as part of the stress response. So when cortisol again remains elevated, insulin demand increases. And then the brain, sensitive to glucose availability and stability, is going to suffer again. It's going to compromise it with our attention, again, with the processing speed. So then what we see is not one broken system, but it's a cascade. Ovarian hormones decline, adrenals are going to pick up the slack, thyroid, insulin production part of the pancreas as well. They all compensate. So again, brain energy metabolism becomes less efficient, cognitive clarity suffers. That's the physiology of brain fog. So it's important to say this clearly. This is not a physiological failure on your part. It's not a personal inability to cope. Yeah, it's an endocrine prioritization. Forgive my English problem. The body is responding intelligently to perceived threats, but the cost is paid in cognitive function. So understanding this is going to reframe our conversation, right? And we're not going to be seeing brain fog as something that we have to push through, but it's a signal, yeah, that systems are getting overloaded, that they are reallocating resources towards survival as opposed to optimization. And so this is also helpful to understand why we can not only target cognition, yeah, we have to look at the whole picture. Memory exercises don't correct cortisol dysregulation. Supplements are not going to override endocrine prioritization, and positive thinking definitely is not going to lower the load. So the support has to meet us where the system actually is. And now here we go again with microdosing that can be considered not as a stimulant, not as a fix, but is more a regulatory support during this period of systemic transition. Microdosing supports neuroplasticity and nervous system flexibility. Sub-perceptual doses, like what you have right now and those capsules, are going to help reduce rigid stress responses and support this neural signaling, yeah? And so we regulate without increasing cortisol demand. Microdosing is not going to replace sleep or endocrine support, but it's going to help the brain move out of this survival rigidity, yeah, into this more adaptive recalibration. That's what we want. So when we talk about stress and brain fog in midlife, we're not talking about weakness. We're talking about our own biology doing its best under pressure. And this is our opportunity to support that biology more intelligently.